You can, if you use the property of definite integrals, you can do a lot of sum in very few steps, which by fundamental theorem, if you do, you will take much more time. Okay. So before that, I would just like to state the fundamental theorem once again. Fundamental theorem of integral calculus. Okay. The fundamental theorem of integral calculus states that if integral a, if integral fx dx is equal to phi x and say plus a constant, then if you take limits in this integral, integral a to b fx dx, then it is the same as taking the limits with phi x a to b, and this you get as phi b minus phi c, phi b minus phi a. You put the upper limit first and then the lower limit. Okay, this is what we have been doing, fundamental theorem of integral calculus. Okay, many applications we have done. Yesterday I also discussed change of variable, that how to change, instead of applying the fundamental theorem directly, how you change the variable, then change the limits, and then apply the fundamental theorem. So that makes things a little easier. If you recall all this that I have done yesterday, okay, then you will realize that I have changed the limits and then use the fundamental theorem. Otherwise, if I use the fundamental theorem at last after evaluating it as an indefinite integral, then it becomes very lengthy. Okay, and sometimes it is it becomes the chances of making mistakes are also very higher. So that is why we use uh, definite integrals. First property of definite integral, property number one, integral a to b fx dx is equal to minus, if you're changing a limit from a to b, suppose if you are making the lower limit as b and the upper, uh, in fact you are making the upper limit as a lower limit, and if you are making the lower limit as the upper limit, then you have got to introduce a negative sign, fx dx. Okay, so an example of this would be, suppose I want to integrate uh, 0 to pi by 2 sin x dx. Okay, in this case, what you do here is, if I want to change the limits, then this will be minus integral pi by 2 to 0. If I want to change the limits, then I introduce a negative sign. See that this upper limit is becoming the lower limit, and this lower limit is becoming the upper limit because of this, and it is same as integrating sin x dx. Okay, so you can evaluate sin x dx very easily. So this is minus,
Yes,
and what
sir.
is the integration of sin x? It is minus cos x.
Minus cos x.
Minus cos x, and the lower limit now becomes pi by 2 and the upper limit becomes 0. Now what you do is you take the minus sign outside, it becomes a plus sign. So this is the same as cos x integrated between pi by 2 to 0. So this becomes, now you put the upper limit first, cos 0, and you put the lower limit, cos pi by 2. Cos 0 you know is 1, and cos pi by 2 is 0. So this becomes 1. Okay, that is how you use the first property. The next property of definite integral is that if you have integral a to b fx dx, then this can be written as integral a to c fx dx plus integral c to b fx dx. But what is c? Where c is a point anywhere between a and b.
B.
C is a point anywhere between a and b. Okay, so this is what this is. Now mostly you will be using this property mostly in statistics later in your bachelor's degree. When you'll be studying BCom, you will be using this in statistics mostly, this integral. Okay. So for the time being, and if this integral was not there in the IC syllabus. Okay, but if we had discussed a continuous distribution, I would have given you an example of this application. Okay, so suppose if I can give you an example here on this integral. Suppose I want to integrate integral 0 to 1 dx by 1 plus x square. Okay, suppose I want to integrate this. Then what I can take is I can take any point between 0 and 1. So let's say I can take 0 to 0.4, 1 by 1 plus x square, and then I can take 0.4 to 1 dx by 1 plus x square. Okay. In fact, you can take any point between 0 and 1. I've taken 0.4, you can take 0.3. It depends on the sum that is given to you. Okay. We'll be using this in one or two problems also later on. A third property, and a very important property, in fact, property number 3. The third property is that integral 0 to a fx dx. In fact, not if I take integral 0 to integral a to b fx dx is the same as integral a to b f a plus b minus x dx. Okay, this is an important property. Understood? We'll be using this property to uh, evaluate some of the problems. And
Okay, sir.
just give me a minute.
Okay, sir.
So this property here, integral a to b fx dx is equal to integral a to b f a plus b minus x dx. Okay, important property. We'll be using this property. Property 4. I can't give you example right now because example the sum will get a little long. So and you'll get confused right now if I give you an example. So better to give you an example later on. The next property that you need to know is integral. In fact, it is actually a derivation of this property only. Okay, let me write it as a deduction. Deduction. If I take a equal to 0, okay, then this integral becomes integral 0 to a fx dx is equal to integral 0 to a f a minus x dx. Very important property. Both of these properties are important because we will have applications of both these properties. Okay, so if you take this lower limit to be 0, then this is the integral that you are going to get. If you put a is equal to 0 in this integral, this is the result that you are going to get. Both these properties you need to know very thoroughly. You will every year you get one problem from either of these two, especially the second one, especially the deduction one. You get a problem from the deduction property every year. Okay, next property number 4.
Okay, sir.
Property number 4 is integral 0 to a. In fact, let me write this as 1 and 2. It is integral 0 to a fx dx is equal to twice integral 0 to a by 2, half of the upper limit fx dx, and this happens if fa minus x is equal to fx. If a minus x is equal to fx, then this is what happens. Okay, so this happens only under this condition. If this is not satisfied, then you cannot write it this way. Okay. Second is that integral 0 to a um, fx dx is equal to 0 if fa minus x is equal to minus fx. Okay. So if fa minus x is equal to minus fx, then directly you can write integral 0 to a fx dx is equal to 0. Next property, property number 5, is integral 0 to 2a fx dx is equal to twice integral 0 to a fx dx. If, again, this happens only if fa plus x is equal to fx. Okay, property should be by heart. Now, although property 4 and property 5
Okay,
you will
sir.
come across very few sums, but still you need to remember these properties. Okay, and next is
Okay, sir.
property 6. Property 6 is that integral minus a to plus a fx dx is equal to twice integral 0 to a fx dx if fx is an even function. You know what is an even function?
Yes, sir.
What is an even function?
Sir, the even one, or like,
Remember this even function. I told you the definition earlier also when I was discussing functions. I repeat this definition. Fx is said to be an even function if f minus x is equal to fx. Then this is called an even function. Let me give you an example. This is for the first one. Let me give you an example for this one, and then it will be clear. Example. Let I is equal to integral 0 to pi by 2. Let's say 0 to let I is equal to integral minus pi by 2 to pi. Say minus pi by 2 to plus pi by 2 cos x dx. Okay, this. Now see here, what is fx here? Here, what is fx? Fx is cos x, right?
sir, fx is cos.
Cosec.
Therefore, what is f
Yes,
of
sir.
minus x? F of minus x is cos of minus x.
Uh,
And you know cos of minus x is cos x. So what are you getting? You're getting fx. So what are you
yes,
seeing?
sir.
Here, therefore, fx is equal f minus x is equal to fx, right? So therefore, you are getting f minus x is equal
Yes,
to
sir.
fx, isn't it? So therefore, this shows that
Fx.
fx is an
Yes,
even
sir.
function. Therefore, you can write directly now. You can write I is equal to integral 0 to pi by 2 twice integral 0 to pi by 2 cos x dx. Understood? You understand the property?
Yes, sir.
Yes, sir.
See, this is minus a to
Yes,
plus
sir.
a.
Open
So
function.
a is pi by 2. So now
Yes, sir.
this becomes 0 to a. So this integral, this minus pi by 2 to pi by 2 suddenly gets transformed to this because f of minus x is equal to fx. Understood? So this is one example.
Yes, sir.
The second one is very
Sir,
interesting. Yes,
sir,
tell me.
the I is equal to integral pi by 2 into e, sir.
So I could not understand. What are you saying?
Integral of, sir, that's the last step. Sir,
Hmm,
wait.
hmm.
Uh, sir, this one.
Tell me, tell me.
This one.
Wait. Mark it. Which step are you talking about? Mark it right now. Mark, mark. Come.
Into
Now you can mark. Mark it. Yes. What happened? What happened? Tell me.
hello,
Yes. Tell me what happened.
hello. This one, the circle one, I have not understand which I have circled.
Okay.
Five
Remove.
to
Okay. Remove the circle. I'm understanding. Remove that.
is
Remove that annotation. I'm making you understand. Remove it. Yes.
can
Remove that.
rejoin because it is because my phone is hanging. I'm rejoining.
Okay. Okay. Now it's gone. Okay. Join again. Once I see that it is an even function, once I've shown f minus x is equal to fx, then this integral from here, from now I can write I is equal to integral, twice integral. See what is the result here? See this. Minus a to a is equal to twice, right? There's a 2. So now I
Yes,
can
sir.
write
Yes, sir.
what is the value of a here? Value of a here is pi by 2, right? So now I can write twice integral 0 to pi by 2 cos x dx. Now it becomes a little easier to evaluate. Okay. And now you proceed with the fundamental theorem, no problem. Clear now?
Yes. Yes, sir.
And the second one is a very important, in fact, very interesting, important definitely, but very interesting also, that if integral minus a to plus a fx dx is equal to 0, this vanishes if fx is an odd function. And what do you mean by odd function? If you remember odd function, I told you f minus x must be equal to minus
It will be
fx.
minus x. Yes,
This is
sir.
an odd function. Okay, so let us see an example here. Example.
Sir, like sin x, it will be minus sin x only.
Yes. Let I is equal to integral minus pi by 2 to plus pi by 2 sin x dx. Okay, this. So here what I do is I say let fx is equal to sin x. That means f minus x is equal to sin minus x, which is equal to minus sin x, which is equal to, now see what is sin x? Sin x is fx itself. So it becomes minus fx. So therefore what do we see here? F minus x is nothing but minus fx. That is fx is an odd function.
Yes, sir.
Now if fx is an odd function, therefore this I now gets transformed to 0. Directly we can write 0. Understood?
Yes, sir.
So that is what this property is. Very important and very interesting property. And that brings us to an end of the properties of definite integrals. Using these properties, we are going to work out sums. Now I'm keeping this for your reference. Okay, I'm starting this in a fresh page here. Okay, so let me start with the some of the basic sums from definite integrals. Okay, let us say problem. Let us say you have, let I is equal to, given evaluate this integral. So you say let I is equal to integral 0 to pi by 2. Always whenever you get an integral, please take it as I. Okay,
Okay, sir.
log tan x dx. It will help you later. Log integral 0 to pi by 2 log tan x dx.
Okay,
Okay,
sir.
now see, this becomes, actually it is very difficult to evaluate, right? If I evaluate only by fundamental theorem, it becomes very difficult, right? You have to use by parts, and then what all you have to do, isn't it? But see, with the help of definite integral, we are going to evaluate it in two
Yes,
lines.
sir.
How? See, this integral can be written as 0 to pi by 2 log tan pi by 2 minus x. Can I write this or not? Why?
Yes, sir.
Because integral 0
Yes,
to
sir.
a, we have done this property, integral 0 to a fx dx is equal to integral 0 to a f a minus x dx. Now check whether you can relate.
Mm, yes, sir.
See,
Same.
see this
Same
property.
thing.
See this property. This one. This property I told you is a very important property. This one.
Yes, sir.
You are using this property. Integral 0 to a fx is equal to f a minus x dx. That is what we have written. So a here is pi by 2. So I have simply written this as pi by 2. So this becomes integral 0 to pi by 2 log tan. Now what is tan pi by 2 minus x? Tan pi by 2 minus x is cot x, right?
Yes, sir.
Yes.
Dx. Now again change cot to tan. This becomes integral 0 to pi by 2 log 1 by tan x dx. Next, I can write this as 0 to pi by 2 log 1 minus log tan x. I can write this way or not?
Yes, sir.
That means this becomes integral 0 to pi by 2 0 minus log tan x. Log 1 is 0 dx. That means this is minus integral 0 to pi by 2 log tan x. So what are we getting here? See, what was our I? I was integral 0 to pi by 2 log tan x, right? See this? We started with this, right?
Yes, sir.
And what are we getting here? We are getting it back,
Yes, sir.
minus I. So what is happening here? Therefore, I is equal to minus I. That means I plus I is equal to 0. That means 2I is equal to 0. That means I is equal to 0.
Yes, sir.
And what was I? I was integral 0 to pi by 2 log tan x dx is equal to 0. Understood?
Yes,
Yes.
sir.
So see how easy it becomes. If you had used fundamental theorem here, it would have become so lengthy. But now since we know the properties, we have just done it in two lines. If we use the fundamental theorem here, then what will happen? You will be ending up using two pages, and maybe you will make a mistake. What would you have done here? If you had used the fundamental theorem directly, you would have done it by parts, and then you would have put the limits. But here, using the property, we can do it very easily. Let us look at the second problem. Problem 2. The problem here is integral 0 to pi by 2 sine square x dx. Now again, if you use your normal fundamental theorem here, it's going to get a little longer, not too long, but definitely a little longer, right? Because you will have to evaluate integrals sine square x. You will have to write it as a multiple angle formula, 1 minus cos 2x, and then you have to do, right? But instead, if you use definite integral, we are going to use the property here. That is, we are going to use the same property, integral 0 to pi by 2 sine square x can now be written as sine square pi by 2 minus x dx. Can we write it this way?
Yes, sir.
We can, right?
Yes, sir. Yes, sir.
I'm not writing the property because you know the property. Next, what we can do is you can write this as integral 0 to pi by 2. This becomes sine pi by 2 minus x is nothing but cos pi by 2, isn't it? Cos x. Sine pi by 2 is cos x. So this becomes simply cos square x dx. Right? Right or wrong?
Yes, sir.
Now,
Yes, sir.
now again change cos square to sine square. You can write cos square as 1 minus sine square x dx. Now what can you write? Now if you separate, you'll get integral 0 to pi by 2 1 dx, so which means simply dx, minus integral 0 to pi by 2 sine square x dx. Okay. Now see, what are you getting? What is integral dx? Integral dx is x evaluated between the limit 0 to pi by 2. And what is sine square x? See that sine square x is it was our given integral, right?
Yes, sir.
So what are we getting here? What are we getting here? We are getting pi by 2 minus 0 minus I. So we are getting pi by 2 minus I. So therefore, what are we getting? I is equal to pi by 2 minus I. This is what we are getting. That means I plus I is equal to pi by 2. That means 2I is equal to pi by 2. That means I
Yes, sir.
is equal to pi by 4. And what is I? Integral 0 to pi by 2 sine square x dx is equal to pi by 4. See, we got the answer very easily. Otherwise, if you had to use the fundamental theorem, it would have become very, very long. In fact, much longer than this. Okay. So this is one. We do another problem from some other property. We have used this property. We'll use the last property now, even an odd function, a problem relating to that. Okay. So let's say I have a function like this. Say I have this. Let I is equal to integral minus 1 to plus 1 x cube by e to the power of 6 minus x to the power of 6 dx. This problem. Now you see the limits minus 1 to plus 1. Whenever you see a minus
Yes.
1 to plus 1 limit, the first thing that should come to your mind is, let me check for even and odd function. So what you do is, you assume let fx is equal to x cube by e to the power of 6 minus x to the power of 6. So therefore, what should be f minus x? F minus x will become minus x cube divided by e to the power of 6 minus x power of 6. So this becomes minus x whole cube is minus x cube divided by e to the power of 6 minus, and minus raised to an even power will give you x to the power of 6 only. So what are you getting? You're getting minus x cube by e to the power of 6 minus x to the power of 6. That means you're getting minus fx. So what can you see? Therefore, we are getting f minus x is equal to minus fx. Are you getting this or not?
Yes, sir.
So we are seeing that f minus x is equal to minus fx. That means fx is an odd function. Fx is an odd function. Therefore, directly you can write I is equal
Yes,
to
sir.
0. You see this property here? This property here, integral minus a to plus a fx dx is equal to 0 if fx is an odd function. And what is the definition of odd function? F minus x is equal to fx. That is why we can write I is equal to 0. That is integral minus 1 to plus 1 given integral x cube by a to the power of 6 minus x to the power of 6 dx is equal to 0. So you see that without evaluating, we just check for even and odd function and we got. So remember, whenever you see a limit like this, minus a to plus a, always check this, whether this is an odd function or an even function. Is that clear?
Yes, sir.
So I stop here for today.